Group 121, Team 6, and today we're presenting our physical prototype for producing biodegradable plastic from seaweed. So the main issue that we saw when we created our project was mainly like all types of plastic being contaminated, not just in the seas, plastic bottles, etc. So the first idea that we had was to use a fungus that could basically disintegrate plastic. It took a lot of time and we ended up seeing that it was really complicated. So we ended up switching to another project. This one was one that we thought was more effective, especially because we think it's more effective to recycling and other alternatives, which is basically using seaweed. This is a really important factor because we found out that we can basically just use seaweed and convert it into basically an alternative to plastic. This is a process that we ended up making for a STEM project, and I'll be explaining it. So the first thing is our prototype demonstrates the process of turning raw seaweed into an eco-friendly bioplastic sheet. First, we start by chopping the seaweed and washing it to remove impurities and to make it easier to process. Then we mix it with water to create a base solution to extract the natural polymers like agar, carrageenan, and alginate. Then we heat it properly in a heat-resistant container or a pot. This is for safety and consistency and is done to low or medium temperature for around like 60 or 80 while stirring continuously. This prevents the mixture from burning and it ensures a gel consistency. So basically what we do is once the mixture becomes thick and sticky, we can add natural plasticizers like glycerin and a small amount of vinegar. And these will help improve the flexibility and the strength. Then we need to stir it again in the pot so that we can make it uniform. So after we have the gel, we put it into a mold and then we spread it evenly with a spatula or a spoon. So then after this, it's left to air dry at room temperature so that after it can solidify into a flexible sheet that we will be using for the bioplastic. So while it's still soft, we have the opportunity to fold it or press it into different shapes like food wraps, containers, or small bottles depending on the packaging. We already have a lot of companies that do this, so we just want to promote it and try to make it a more effective solution because it's not really that popular. So this would be the result of our prototype and what we hope to achieve.